All right, ladies and gentlemen, hello and welcome to a very special DM radio episode. Yours truly, Eric Kavanaugh, here with an all-star cast. We've got Mark Madsen of Third Nature, Denise Mico of Ravel, and Rich Lappenbush of Super Micro. We're going to talk about all kinds of fun things, orchestration of AI workloads. We're going to talk about AI factories. What is GPU as a service? How can you get the most from your infrastructure? Do you have the right infrastructure? And we're going to start off with a bit of a presentation by Mark Madsen. So, Mark, take it away.
Oh, good morning, everybody. I guess I will just jump right in then.
Yeah.
So, the purpose of this presentation is really to frame some topics for discussion with the expert panel that we have and help you to think about the questions to ask, right? Because a lot of this isn't answering, there's not one answer to things. So, I'm just going to jump right in with our show. All right, so. The real question is about AI infrastructure and whether you have the right infrastructure. A lot of organizations have evolved over the years, uh, via things like transaction processing, which was the early pieces. Then we started to get into analytic processing, build business intelligence systems and data warehouses. Along the same, time, we started to add things. Email is an obvious and classic thing that's been around for decades, but also collaboration systems and different types of communication collaboration systems for document management. And the interesting thing is that if you look in IT as an enterprise architect, each of these is its own domain with its own technologies, its own stacks, and they're all just a little bit different because the processing and the use is a little bit different. And so what we have now is a shift to, well, first machine learning and data science, and now AI, which is much more like high performance computing, which is what the HPC stands for. And for most organizations, that has been a net new addition to IT coming from a different space. Originally, HPC was mostly government and research labs with big clusters of computers and supercomputers. And now we have teraflops in a single server. And so it's enabled a lot, and AI and machine learning workloads demand this. And so what's happening in the market now is everybody's on another modernization binge, equivalent to the cloud binge that started 10 years ago. If you look at plans that people are stating, according to the surveys, about 50% of companies are looking at modernization within the next 18 months. And that's going to be a significant investment, but the question is, what? What are you trying to get? And the easy answer is just go out and buy some GPUs, stick them in servers, or just use cloud. But it's never that easy. These things are stacked on top of each other, right? There's infrastructure on top of infrastructure. You've got facilities that need to have the right power management and power supply. You need extra cooling costs if you have a lot of AI servers or GPU servers. You need different networks. And then on top of that, you've got all of these other bits and pieces. And so there's more components that make up the subsystems that all have an impact on the usability of your systems, the time to do work, the cost, the performance as a whole. The basic point being that there isn't a one size fits all answer where you just go to Amazon or you just go to Google or you just buy a server from somebody. You have a set of decisions to make. And you can tell that this is a problem and that this is new to IT organizations because of the problems that people are facing. We've got all kinds of complaints as obstacles, right? Two of the big obstacles that are reported over and over again are lack of skilled people, that is, expertise in-house to find, procure, design, configure, and operate the systems, and uncertainty about what will actually work. And on the other side, you see statistics like the big one, 65% of companies saying that they've got idle resources. And that means that you spent money on something and you're not using it, right? So you spend money, you're not using it, or you don't have the right thing, right? You've started in one area and then the actual production workload looks completely different. Or the forecast initially was for one thing, the new forecast is three times as much because you've got some experience with it now. And so, large number of companies in this particular survey by DDN, over 70% saying that upgrades need to happen, retrofits need to happen. And everybody's talking about today's hot topic too, energy usage. We need to be more energy efficient. These things are power hungry. We want to build new power plants to supply data centers. And everybody's looking at ways to cut those costs. And yet 60% of the companies, 59 in this case, are saying investments aren't getting the results that people want. So these are the kind of problems, and these are infrastructure problems because you have the wrong things. But the real question then is what infrastructure, if it's not just servers or a data center? And you have to break this down and look at what you need. Some companies have been doing machine learning for a long time and they already understand this. Others haven't read the Google paper, Machine Learning, the High Interest Credit Card of Technical Debt, which is about 10 years old at this point, and don't understand all the bits and pieces that are needed to put these things into production. And if machine learning basics was that, the newer AI systems are the payday loan lenders that you go to pay off your credit card. So they're even worse because you're stacking your application on top of workflow and operations to keep the system up, which requires specialized software infrastructure, the AI platform layer, GPU optimization, and specialized software development kits, and all of that sits on top of core infrastructure. Hardware that is designed specifically to run high compute and high data workloads, sitting on top of the physical infrastructure, networks, and power and cooling, and so on, designed to support that equipment. And so it's a whole nested set of dolls. And it's not one thing you go out and buy, right? It's multiple things, which I broke out into these arbitrary layers because it's how I approach the problem. But companies like AI managed service providers have tried to bundle these things up to make it easier for you. Um, Both cloud vendors and neo cloud vendors who are specialty only focused on AI or managed service providers even are now touting what they call AI factories, where they have tried to kit up and put these things together so that you have a one-stop shop. But there are trade-offs involved in doing this. And the real question in this is for your application or for your need, what do you use? What do you need? And also timing. When do you need it? Because the lead time, depending on what you do, can be very significant. And that goes to workloads. What kind of workload do you have? Now, in this sort of thing, I like to use analogies because I find I find it sometimes hard to discuss because you look at things and you say it's just software or it's just computers and networks, right? There's just this one thing. It's too abstract. Now, years back, I used to deal with logistic problems a lot. Logistics, specifically in chocolate, right? So, how do you transport this stuff was one of the questions, and why is logistics so difficult for us? Well, it's because we ship different things because customers have different needs, right? There's powdered chocolate. There are these wafers. Wafers get sent to confectioners and people like that who melt stuff down, or to bakeries and patisseries. You've got liquefied chocolate, which is used when you're actually making chocolate and sending it to a candy maker who coats chocolate. So you've got different forms. You've got small buyers, right? A small bakery. You've got big buyers, big candy makers. You've got locations, you've got different times of year, right? Shipping chocolate to Arizona when you don't want it to melt requires refrigerated trucks. And so we end up with a truck fleet that's got some lease and some rental, right? Seasonal uses. We don't need the trucks year round with refrigeration. We only need them for a period of time. Liquid transport is really difficult because you have to actually heat the chocolate and keep it sanitary while you truck it around the country. And so you have all these different needs. So different payloads, different volumes, different needs, hot, cold, so on, require different engines. And AI is no different than this. It's not one thing. There are different AI techniques, automated reasoning, generative AI, which is what everybody usually talks about. All the machine learning techniques that we've been using for the past several decades at this point all require different amounts of compute, of storage, of memory, of networking. Some require clusters and fleets and some don't. And so we have to look at that and we have to look at the timing, right? It's not just what do you need, but when do you need it? Most emphasis in the market is still, because it's early, focused on developers, on building. So people talk about prototyping and doing pilots, right? Prototypes are doing experiments. There's high variability. There's a lot of data processing, training, retraining, and it's very spiky workload. When you get to a pilot, typically you put things out there in front of people. This is, production pilot to a limited group. That's the whole point of a pilot. At which point you discover problems and you have these spikes of retraining that go up and down. And and then you stabilize. And when you've figured out what you're doing and it's good enough, you move into deployment and operations. And so now you release it out into the wild, either in your company or externally. And there will be some hiccups. You'll have to do some retraining. You'll have periodic model calibrations that require big clusters of compute. But the switchover is really from a training heavy workload to what's called an inference heavy workload. And that takes different activities because now you're worried about service level agreements, you're worried about latencies, you're worried about making sure that the system stays available. Whereas in prototyping and piloting, it's okay to have those hiccups and outages, but that's absolutely not the case in ongoing production work. And so you end up with different mixes of work, and they all have different needs. And it's based on your application. Are you doing predictive analytics or forecasting? Are you doing language processing, old school, which is computational linguistics? Are you doing language processing, new school, which is generative AI, chatbots, RAG, things like that? And they take different training, they take different post training, and so on. And they define workloads. The techniques map to workloads. Some have heavy training requirements and some are light. Some use a lot of compute on inference, some use little. Little known fact is that about 70% of the machine learning market, which includes AI, is run off of CPU inferencing, not GPU inferencing. The GPUs are used to build the models, the CPUs are used to run them. Right? And then there's the data prep and the data flows that have to run, and all of that needs to run in things. And so you have to make trade-offs. And the real question is, where are your constraints and where are your preferences? They sit on these axes, and there's many. It's what's important to you. I just mapped out a handful that I tend to look at a lot. Is this a lot of users or few users? That's high versus low concurrency. Is it an IO intensive workload with a lot of data, or is it something where small amounts of data go back and forth, and so on? You need to map out these things so that you can understand what's important to you so you can map that to the workload because there's so many options to choose from, right? You can buy servers and stick them in your data center, but you may need to retrofit your data center. Or maybe you're doing things at such scale, like a pharmaceutical research lab, that you need 300 servers and you can't do that in a data center. So you have to go to a modular data center or maybe a neo cloud to lease infrastructure. Or maybe you just rent from cloud, right? Low-end GPUs in Amazon are $10 an hour, which sounds great until you realize that a 7-year-old GPU costs you $3,650 when you can buy one off eBay for 200 bucks. And that leads you to the timing issues again. When do you need which things? Because if you need things at different times, maybe there's a mix of owning and leasing and renting, which is why almost half of the companies with things in production are using hybrid models. So your real questions are, what workloads, trade-offs are important to you? What constraints do you have in place over those? And what trade-offs do you have to make between those? And those are the questions that we're going to discuss on the radio show, which is coming up shortly. Eric, I'll turn this back over to you.
All right, folks, we're about to start our radio show. And guests, you can ask any question anytime. Don't be shy. Feel free to do that, and we'll get rolling in just 1 second.